we want to know the average power, and this is the data that we have. The mass, that is 800 kilograms, the time, that is 2.50 seconds, the velocity, that is 1.70 meters per second, and we have to know the average power. And to know this, the formula says that the power is equal to the force times the velocity. And to know this, we don't have the force, so we have to know the force, and we use the formula that is force equal to the mass times the acceleration, but we don't have the acceleration, so we have to know the acceleration, and we use the formula of the acceleration, that is acceleration equal to final velocity minus the initial velocity over the time, and we substitute the values that we have, and then the result is 0.68 meters per second squared, and so we know the acceleration, and then we substitute the value of the acceleration in the formula of the force, and we substitute the values, and we finally know the force, that is 544 newtons. Then we substitute the values that we already know, and we divide over 2 because it's the average power, and the power is equal to 462.4 watts.
So now we have to know the power in constant velocity, and we know that the velocity is equal to 0 when it's in constant velocity or when it's in rest. So the formula is power minus mass times gravity. We clear the power, that is equal mass times gravity, and we substitute the value that already have, and the result is power is equal to 7,840 watts.
To answer the second question, that we have to know what is the difference between a power with constant speed and average power, we have to do a subtraction between power with constant speed and average power. So this is the values of each one, and we substitute the values in the subtraction. There is 7,840 minus 462.4, and the result is this one.
Our project consists of calculating the speed of a car at the bottom and at the middle of the height of a roller coaster called the Leviathan. What we first did was the data list is the mass is equal to 50 kilograms, the height is 90.3 meters, and we need to find the velocity at the middle and at the bottom. That is the velocity medium and velocity final. We started with calculating the potential energy with the formula, that is potential energy equals to mass by gravity by height, and we got for the initial potential energy we got 45,717 joules, and for the middle it was 22,858.5 joules. And well, that's for the potential energy. And then we started with the velocity at the middle of the height. That is, we use the formula the root square of 2 by kinetic energy over mass. And we substitute the values, and for the medium energy we have medium velocity, we have 30 meters per second, and for the final velocity 42.76 meters per second. And that was our final values and the answer.